In example 5, we're being asked to find the equation of a tangent line. So first thing is, when we find the equation of a tangent line, we really should use the point slope form. It's much easier to use than and much more convenient than finding the y equals mx plus b. So to find the equation of a tangent line, what I want to do first is I want to differentiate this. So I'm going to first of all find the derivative. So I'm going to find f prime. I need to use the product rule, so I'm going to differentiate x. I get 1. I don't differentiate the cos. Then I differentiate the cos into negative sine x. So there's my derivative. I'm going to just simplify that a little bit. So I end up with cos x minus x sine x. Okay, and then I want to calculate the slope, so I want to find the f prime at pi over 2. So plugging pi over 2 in, cosine of pi over 2 is 0, x is pi over 2, sine of pi over 2 is equal to 1. So slope is equal to negative pi over 2. So that's my slope. Now, to find the equation of a tangent line, I actually need to have an x and y coordinate. So I'm going to find the y coordinate here. So I'm going to plug in f of pi over 2. So not f prime, but f of pi over 2. And I end up with pi over 2 times cosine of pi over 2, which is 0. So I get 0. So when x is pi over 2, y is equal to 0. And so I have now my equation. So I can write my equation based on y equals mx. Okay, so I'm going to go x minus pi over 2. That's my coordinate on the curve, plus 0, which is the y coordinate on the curve. And then I need to plug in the slope. Negative pi over 2 was the slope. So this represents the equation of my tangent line. For the next one, we're going to differentiate implicitly. So looking at this, I first of all need to find my embedded y function. There it is. So I'm going to differentiate everything normally. So I'm going to differentiate 9y cubed, y to the power 2. But since y is embedded, I need to apply my chain rule and get the y prime. The rest of this is just differentiated normally. And then what's implied is I need to solve for y prime. So I get y prime is equal to positive 2x, and then I'm going to divide by the 9y squared. So my y prime is a function of both x and y coordinates. So to solve for y prime, to find the slope, I need both the x and the y coordinates to do that. For the next one here, we're going to do the same thing. We want to identify the embedded function y here and here. In the first one, I have to make sure that I use the product rule here. Okay, so I'm going to take the 3 out, and then those brackets I'm going to apply the product rule. So I get x times, sorry, not x, but 1 times y plus x. I don't differentiate the x, but I differentiate the y prime. Okay, so there's my product rule, minus 4x plus 2y, and because I differentiated a y, I need to again apply the chain rule. Okay, this time I'm going to group my y primes together. So I'm going to get 3x y prime. I'm doing this because I have more terms here, so I just have to be a little bit more careful. So 2y y prime, and then I'm going to move the other terms to the other side. So I get minus 4x becomes plus 4x, plus 3y becomes minus 3y. I'm going to factor out the y prime. Okay, and then the last step is to divide both sides by the coefficient to get the y prime. So y prime as a function of both x and y is going to be 4x minus 3y, and that's all going to be divided by 3x plus 2y, and I'm just going to leave it like that. So there is my implicit derivative. It's a function. It's an implicit function in terms of x and y. So I need both an x and y to be able to calculate the slope.